Every single engineer is limited by the tools they use because, well, the tools you use literally shape what you believe is possible.
Yeah, that is it's a massive statement to kick us off with.
Right. Just sit with that for a second. It's an incredibly heavy concept when you really think about it.
It really is. I mean, historically, we like to believe we're in absolute control.
Oh, totally. We think we're the visionaries.
Exactly. We view ourselves as the undisputed masters of the domain, and the tool is just this, you know, this dumb instrument executing our will at the end of our fingertips.
Like a hammer. A hammer doesn't tell you what kind of house to build.
Right, and a wrench doesn't decide how the engine goes together.
Even a compiler, right. It doesn't tell you how to structure your application's logic. It just compiles.
But that's exactly why we need to unpack this today. Because if you step into the world of software engineering right now, especially with this massive explosion of agentic coding, that whole relationship is completely flipped on its head.
It really is. The tool is no longer passive. It actually has opinions now.
Strong opinions, it has strict boundaries, it has safety rails.
And if you aren't incredibly careful, the tool's structural limitations basically become your own cognitive limitations, and you don't even realize it's happening.
Which is the exact paradigm shift we are dissecting in this deep dive.
Yes, our mission today is for you, the listener, to figure out how to break past those invisible limitations of out-of-the-box tools. We're exploring this amazing breakdown by Indy DevDan.
Yeah, he's a prominent voice in the developer space, and he highlights this fascinating schism that's happening right now in AI engineering.
It's like we're moving away from these polished, user-friendly, walled gardens of commercial AI, and we're taking you straight down in the engine room, just glowing terminal screens, raw wires, and deep, deep technical customization.
I love that visualization, and it's so necessary right now because if we look at the undisputed heavyweight champion of this space, the tool everyone's talking about, it's Claude Code by Anthropic.
Right, which is mainstream, it's heavily funded, and honestly, it is incredibly powerful.
It is. But Indy DevDan introduces this insurgent, highly customizable open source alternative called Pi, P-I.
And we're going to use Pi to show you how to avoid getting trapped in what's being called the middle of the distribution.
That concept, the middle of the distribution, that is critical for anyone listening to understand.
Right.
The stakes for how digital products are being built today, they couldn't be higher.
I mean, for decades, coding was manual. You typed every line.
Right. Then we got autocomplete on steroids with early AI tools like Copilot. But now we are fully in the era of agentic coding.
Which is fundamentally different.
It's totally different. This isn't just asking a language model to spit out a single Python function anymore.
No, you are giving an autonomous agent an overarching business goal.
Exactly. It independently reads your file system, it executes bash commands, writes code, runs its own tests, reads the error logs, and it iterates until the software works.
It's essentially spinning up a digital junior developer directly inside your laptop's terminal.
Precisely. And Claude Code basically proved that this architecture could work at scale. It lowered the barrier to entry so much.
Yeah, to the point where a product manager or a designer or just a weekend hobbyist can jump in and get immediate value.
But, and this is the absolute crux of the issue for you listening, whether you're a seasoned senior architect or just a curious tech enthusiast, that massive accessibility comes with a deeply hidden cost.
We are entering the age of slop.
The age of slop.
I mean, think about it. If everyone is using the exact same default AI tools, constrained by the exact same default system prompts, and gated by the exact same safety rails, everyone is inevitably going to produce the exact same generic software architecture.
Exactly. You face a total homogenization of software.
Everything starts looking and functioning exactly the same.
Because if you rely entirely on the out-of-the-box experience of a commercial agent, the logic structures it chooses, the libraries it defaults to, the problem-solving paths it takes, they're going to be identical to the outputs being generated by millions of other developers using that exact same tool.
So relying on default configurations is essentially a guaranteed ticket to being average.
Right. If you want outsized, specialized outcomes, you have to literally build and customize the tool that is building your product.
Which leads us directly into the first major section of our deep dive today. The fundamental philosophy clash between a market leader like Claude Code and an open source insurgent like Pi.
And Indy DevDan makes a brilliant, albeit pretty aggressive observation about Claude Code here. I mean, he loves it. He uses it constantly.
Yeah, he's a fan.
He is, but he notes that it has caught the curse of success.
I found this part so fascinating because it speaks to the entire life cycle of enterprise software. Anthropic is a brilliant company, but they're a massive for-profit entity.
Right.
When a tool like Claude Code becomes wildly successful, its DNA fundamentally changes. It can't just be a sandbox for hardcore hackers anymore.
No, it has to secure massive enterprise contracts with Fortune 500 companies.
And what do Fortune 500 companies demand above literally all else?
Safety, stability, and absolute predictability.
Yep. To maximize that broad user satisfaction across an entire enterprise, Anthropic has to prioritize those elements over the hyper-niche, highly experimental needs of a senior engineer.
And you see it happen month after month with product updates. More features get abstracted away behind sleek interfaces. You lose access to the raw wires.
You get rate limits imposed on you.
Exactly. And the agent is strictly forbidden from executing certain types of system-level commands just to prevent liability.
It's the classic trajectory of a tech product. You start with this razor-sharp tool for power users. It gets super popular, and suddenly it is wrapped in 6 layers of bubble wrap so the accounting department doesn't accidentally delete their own hard drives.
That's a great way to put it.
But that bubble wrap is incredibly stifling if you actually know how to use the razor.
Which is precisely the vacuum that Pi was built to fill.
Let's talk about Pi. It was created by a prolific engineer named Mario Zechner, right?
Yes, who also built the engines for other open source projects like OpenClaw, Maltbot, and Clawbot.
The guy is busy.
Very. But Pi operates on a radically different, almost militant wavelength compared to those enterprise tools. Its foundational rule is simple. If I don't need it, it won't be built.
Radical minimalism. Indie Dev Dan points out that Pi's catchphrase is actually a riff on the Rifleman's Creed.
Oh yeah, there are many coding agents, but this one is mine.
Exactly. It's designed from the ground up to be aggressively unopinionated.
Let's drill down into that word opinionated, because in software engineering, that term carries massive weight.
It really does. An opinionated tool forces you to work the way its creators think you should work.
Right, and the most glaring example of this in the AI space is the system prompt.
Oh man, the system prompt comparison in the source material was eye-opening. For anyone listening who might be unfamiliar, a system prompt isn't the question you type into the chat box.
No, not at all.
It's the invisible, foundational set of instructions the AI reads before it ever interacts with you. It defines the AI's entire personality, its rulebook, its boundaries.
And Claude Code uses a massive, dense 10,000 token system prompt.
10,000 tokens. That is huge.
It is. What's fascinating here is analyzing what those 10,000 tokens actually consist of. Anthropic is essentially preloading the agent with 10,000 tokens of their own corporate opinions on what constitutes best practices.
So it's telling the model how it should handle error looping, what tone of voice to use, how to structure its file edits.
Exactly. Which bash commands are strictly off limits, and exactly how to deflect user requests that violate its safety parameters.
I see what you're getting at. It's like hiring a master carpenter, but before he's allowed to touch a single piece of wood, his parent company forces him to read a 500-page legal manifesto on exactly what angle he is allowed to swing his hammer.
That's a perfect analogy.
And he's physically incapable of swinging it any other way, even if the specific joint he's working on requires a different angle.
Right, and for a junior developer, that 500-page manifesto is a total godsend. It prevents them from pushing catastrophic bugs to production.
Keeps them safe.
It does. But for a senior architect who has spent 10 years developing their own highly specific mental models for system design, or someone who is working on a weird experimental edge case that breaks standard conventions, those forced opinions are agonizing.
You just end up fighting the tool.
You end up spending way more time fighting the tool's guardrails than actually engineering your product.
Enter Pi. While Claude uses 10,000 tokens of rules, Pi uses a bare-bones 200 token prompt.
200, it's almost nothing.
It essentially boots up, points to the terminal, and says, "You are a coding assistant. Here's the environment. Let the model cook."
It completely trusts that the underlying intelligence of the LLM is sophisticated enough to reason through the problem without being micromanaged by a giant corporate rulebook.
But, and this is a big but, that total lack of micromanagement leads to the most controversial aspect of this entire philosophy.
The total abandonment of artificial safety rails.
Okay, here's where I have to throw a flag on the play.
Yeah.
Because Indie Dev Dan straight up claims that security and agentic coding is mostly theater.
He does say that, yeah.
And because of that philosophy, Pi defaults to what is affectionately called YOLO mode.
You only live once mode.
Right. You turn it on, and this autonomous AI has full, unrestricted read and write access to your entire local device.
Your file system, your terminal, your network ports, everything.
Everything. Running an agent with zero safety hooks feels less like a coding tool and more like handing a highly caffeinated intern root access to your production database and just walking away for the weekend. I mean,
Oh.
isn't that just begging for a complete system wipe?
It sounds terrifying, I know, but if we connect this to the bigger picture, it explains exactly who Pi is built for. Pi is absolutely not for the intern.
Okay.
It is for the lead architect running a highly controlled local environment. The argument here is that for power users, artificial safety rails actually destroy the entire value proposition of having an autonomous agent in the first place.
What do you mean by artificial safety rails? Like the pop-ups?
Exactly. Imagine the agent pausing to prompt you with a yes or no confirmation every single time it wants to execute a simple directory listing or a grep search.
Right, because if I have to sit there hitting Y on my keyboard every 30 seconds, I'm not gaining any actual leverage. The safety features devolve into speed bumps that completely kill the agent's momentum.
Precisely. Pi's underlying philosophy is one of absolute trust in the user. It assumes you, the human engineer, are smart enough to isolate your environment, use version control, and not explicitly instruct the agent to recursively delete your root directory.
So they assume I have my own backups and sandboxes.
Right. And in exchange for you taking responsibility for your own environment, the agent is allowed to run at absolute unthrottled lightning speed.
It's the ultimate trade-off between safety and velocity. And this unthrottled freedom extends directly into how Pi handles the actual brains of the operation, which is its model agnosticism.
This is a huge point. Claude Code, quite naturally, funnels you toward Anthropic's proprietary cloud models like Claude 3.5 Sonnet.
Which, to be fair, makes perfect business sense for them. They built the tool to sell the model.
Of course. But Pi is completely agnostic. It doesn't care whose ecosystem you prefer.
So if you want to use the API for Google's Gemini 1.5 Pro because of its massive context window, you can just plug it in.
You can. Or if you want to use a highly specialized, localized open source model like GLM4 or Minimax, Pi natively supports it.
So let's break down why that actually matters mechanically for you listening. If I'm a developer, how does swapping the model change my day-to-day engineering?
It fundamentally changes the logic trees of your entire workflow.
How so?
Think about it like this. Different AI models are essentially different brains, right? They're trained on different distributions of data, so they have distinct personalities.
Okay, I track that.
Some models are incredibly fast and cheap, but their reasoning capabilities break down during complex asynchronous logic. Other models are brilliant at deep architectural reasoning, but are incredibly slow and cost an absolute fortune in API credits.
And some are explicitly overtrained on Python, but might struggle with obscure Rust library.
Exactly. By being truly model agnostic, Pi allows you to swap out the brain of your agent on the fly, tailoring the underlying intelligence to the specific microtask at hand.
That is massive. You aren't locked into one single corporation's vision of what intelligence actually looks like.
Yeah, you have total control.
But as with all things, that absolute freedom comes with a significant burden. Because if Pi isn't providing the guardrails, or the UI, or the opinions, you have to build all of that yourself.
Yes, you do. Which takes us into the mechanics of Tier 1 customization and mastering what is known as the agent harness.
This is such a vital distinction to make for anyone getting into AI engineering right now.
Yeah,
People constantly conflate the model with the agent.
constantly. But they're two entirely different layers of the stack.
Let's clarify that for the listener. The model is just the brain, right? The large language model, the neural network predicting the next token, sitting on a server rack somewhere.
Exactly. The model itself cannot actually do anything. It's just a text prediction engine trapped in a box.
Right.
The agent harness is the physical infrastructure built around that brain to give it hands, eyes, and memory. The harness manages the context window. It provides the terminal interface you look at. It handles the API routing. And most importantly, it defines the tools the model can actually wield.
The hands.
Mm-hmm.
And Indie Dev Dan shows that Pi provides the absolute bare minimum harness out of the box.
It gives you almost nothing to start with.
It gives the agent exactly 4 default tools: read, write, edit, and bash.
That is it.
That's it. It can read a file, it can overwrite a file, it can patch a specific line in a file, and it can execute a command in your terminal.
Everything else, literally every other capability, you have to build into the harness yourself using extensions.
And this is where the customization becomes incredibly granular. And it starts with something as seemingly trivial as the user interface. The UI customization segment of this deep dive is wild. Because Pi is a terminal-based CLI tool, you'd assume it would be pretty rigid. Just, white text on a black background.
Right, like a standard command prompt.
But you can manipulate the UI based entirely on your immediate psychological state. For example, the source discusses this pure flow extension.
Oh yeah, I love this concept.
If you are deeply focused on a complex problem and you don't want any visual noise, you can strip the terminal UI down to literally nothing but a single blinking input bar. No toolbars, no token counters, no model names, just you and the agent in a digital void.
It's essentially the coding equivalent of a sensory deprivation tank.
It really is. But then, if you shift gears to a task where you need maximum observability, say you're debugging a massive context failure, you can stack UI extensions like Lego bricks.
You can program a custom footer that displays exactly how many tokens are left in your context window.
You can see the real-time cost and sense of the current API call.
Yep, the specific model weights currently loaded and the active Git branch you are working on.
All dynamically rendered in your terminal. And this modularity extends into pure aesthetic rendering as well.
Oh man, the themes.
Yes. Indie Dev Dan gets really enthusiastic about this theme cycler extension, giving a huge shout out to this Neon Synthwave 84 theme.
Where the terminal turns hot pink and purple.
Yeah, hot pink. And look, I appreciate a cool aesthetic as much as anyone, but here's where I have to play the skeptic for a minute.
Go for it.
This sounds exactly like a developer spending 4 hours meticulously customizing their Vim configuration and terminal font colors instead of actually writing the software they are getting paid to write.
I know exactly what you mean.
Like, is tweaking neon themes and custom footers actually a form of high-level engineering, or is it just highly elaborate system-level procrastination?
It's a fair question. What's fascinating here is how easily this is dismissed as mere aesthetic procrastination. But if you talk to high-level architects, it is actually a deeply intentional practice of cognitive load management.
Cognitive load. Okay, you're going to have to explain how a neon pink terminal saves cognitive load.
Well, it's not about the color itself, right? It's about spatial predictability.
Spatial predictability.
Yeah. When you are deep in complex system architecture, your brain is holding this massive, fragile house of cards in its working memory. You are tracking data payloads passing through 5 different microservices.
You're in the zone.
You are. And every single time you have to shift your conscious attention to look for a piece of meta information. Like, wait, did I switch back to the Peeper model for this script? Or how close am I to blowing my token limit?
You break that deep focus.
You do. You drop a card from the house.
So having to consciously search the screen for context burns your actual mental RAM.
Exactly. By forcing the engineer to explicitly define where every single component loads in the terminal, Pi allows you to build a bespoke dashboard that aligns perfectly with your unique neural pathways.
That makes a lot of sense.
When you design the UI yourself, your eyes instinctively know exactly which pixel to dart to in order to find the token count, without your brain having to process the search.
It's like a fighter pilot designing their own custom cockpit.
Yes. Perfect analogy.
They wire the missile lock button to the exact millimeter where their thumb naturally rests. It's not about making the joystick look cool. It's about shaving off milliseconds of reaction time and preventing mental fatigue during a dogfight. You are literally hard-coding the UI to your reflexes.
Exactly. And because these extensions are stacked programmatically, you can create entirely different cockpits for different modes of work. A sparse cockpit for deep architecture planning, and a data-dense cockpit for debugging.
You are saving human context switching time by making the machine adapt to your immediate psychological requirements, rather than forcing your brain to adapt to Anthropic's generic one-size-fits-all interface.
Which is incredibly powerful when you're working 8-10 hours a day on complex code bases.
I buy that. The psychology of UI is very real. But let's move from how the tool looks to how it actually behaves.
Okay. Let's get into it.
Because we established earlier that Pi operates in this wild, unthrottled YOLO mode without safety nets. If we stripped away all the guardrails, how do we keep this hyper-fast autonomous agent from hallucinating, running the wrong bash commands, and basically careening off a cliff?
This is the crux of the entire deep dive today. We have to replace artificial manual safety with structural determinism.
Structural determinism, right? And Indie Dev Dan highlights a massive breakthrough here. It's a custom 700-line TypeScript extension he wrote for Pi called Till Done.
Till Done. And this single extension fundamentally rewrites how the AI approaches problem solving.
Let's trace the actual code execution of what this extension does because it is a brilliant piece of agentic engineering.
Let's do it. Normally, if you tell a standard AI agent to explore an unfamiliar code base, it relies heavily on improvisation.
which can be messy.
Very messy. It might blindly execute an else command to list the directory, see a folder, open a file, read it, get distracted by a weird function in that file, open another file, and completely lose track of its original goal. It is chaotic and non-deterministic.
Right, it's acting like a human with ADHD,
Yes.
just bouncing from shiny object to shiny object.
Exactly. The till-done extension stops that improvisation at the system level. It uses what are called execution hooks to physically intercept the agent's actions before they hit the terminal.
How does that work in practice?
So, for example, the agent decides it wants to run a basic ls command to look at a folder. It formulates the command and tries to execute it, but the custom TypeScript hook catches it in midair.
It just intercepts it.
Yep. It uses regex to parse the command, halts the execution entirely, and injects a new system prompt back into the agent's context window saying, access denied.
Which is such a wild concept.
Yeah.
You build this massive, highly capable autonomous brain, and the very first thing you do is structurally slap its hand away from the keyboard.
I know, it sounds counterintuitive. But the rejection isn't a dead end. It comes with a strict condition.
What's the condition?
The hook essentially tells the agent, if you want to run this command, you must first format your intent into a strict JSON to-do list. You must add the task to the list. You must mark the task as in progress. I will validate your JSON structure. Only then will I release the lock and allow you to execute the command.
And then what happens after it runs?
Once the standard output returns, you must update the JSON to mark the task as done.
Okay, I really had to challenge this logic.
Bring it on.
The entire promise of the AI revolution is autonomy, right? We want these agents to be fluid, smart, and capable of human-like reasoning.
Yes, generally speaking.
If we are writing 700-line code hooks to block its natural actions and forcing this cutting-edge neural network to fill out a rigidly formatted JSON to-do list like some heavily scrutinized middle manager, aren't we defeating the entire purpose of having a smart agent?
It seems like it.
I mean, why not just write a standard old-school bash script if you want it to be that rigid?
This raises a profound point about the current state of artificial intelligence. It highlights the central paradox of automation right now. True, scalable autonomy actually requires rigidly predictable micro-interactions.
Predictable micro-interactions.
Yeah.
Break that down for me.
Think about the difference between what is known as in-loop versus out-loop agentic coding.
Okay, let's define those.
In-loop means you, the human, are sitting at the terminal. You watch the AI type. You chat with it. When it hallucinates a file path or gets stuck in an error loop, you manually hit Control-C, you course correct it, and you tell it what to do next.
You are the safety net. You are part of the loop.
Exactly.
You're just babysitting a very fast typist.
That is exactly what you're doing. Now, out-loop is the holy grail. Out-loop means you give the agent a complex architectural command, you lock your laptop, you go get dinner, and you come back 3 hours later expecting the entire microservice to be built, tested, and deployed perfectly.
But you can never achieve out-loop autonomy if the agent is improvising.
Precisely. If the agent relies on improvisation, the mathematical probability of it eventually hallucinating a variable, getting stuck in a circular dependency, or breaking a build script approaches 100%.
Because the more steps it takes, the higher the chance of a hallucination compounding.
Yes. And because you aren't there to hit Control-C, the whole process crashes and burns in the first 10 minutes.
I see.
By forcing the agent into this highly rigid deterministic loop, create task, start task, execute, verify, finish task, you eliminate the chaotic improvisation. You force the AI to operate as a predictable state machine.
Oh, I see the matrix now. You are deliberately constraining the agent's process so that you can mathematically trust its outcome. You trade fluidity for absolute reliability.
And IndieDevDam points out a massive, massive economic and computational benefit to this deterministic harness. It completely changes which models you actually need to use.
The dumb models. This is the most counterintuitive part of the whole breakdown for me.
Well, it's brilliant, though.
Because the till-done harness is enforcing this incredibly strict, idiot-proof procedural loop. The agent physically cannot get confused.
Right.
Which means the engineer no longer has to pay for the most expensive, hyper-intelligent reasoning models like Claude 3.5 Sonnet to do the heavy lifting.
Right. They can swap the brain out for what is categorized as a bottom third intelligence model. The specific example used in the source is Anthropic's Haiku model.
Haiku is super fast, but yeah, it's generally not trusted for deep, multi-step architectural reasoning on its own.
But they give it a massive, highly complex task. They instruct this lightweight Haiku model to map out every single TypeScript file in a sprawling code base, format those relationships into a hierarchical markdown tree structure, and write a concise one-sentence summary for every single file.
If you just asked a raw, unharnessed haiku model to do that via a web chat, it would probably get lost halfway through folder 3.
Oh, absolutely. It would experience context collapse, forget its original formatting instructions, and start hallucinating files that don't even exist.
But because haiku is trapped inside the tilde harness, it is forced to operate sequentially.
Exactly. It realizes it needs to read the file system. The harness blocks it and demands a plan. Haiku generates a structured JSON list of maybe 16 distinct tasks. The harness then forces it to execute task 1 in isolation.
It reads the file, it summarizes it, it updates the state to done.
Then the harness feeds it task 2, read file, summarize, mark, done.
It's literally like putting blinders on a horse. You remove the overwhelming scope of the entire project and force the model's attention span to focus entirely on the very next micro step.
And the result? The lightweight model completes the massive, complex task flawlessly. But because you are using a haiku instead of sonnet, the entire operation executes at 10 times the speed, and the API cost drops from dollars down to a fraction of a penny.
That is incredible.
You achieve a superior outcome, saving cash and repeat time, not by buying a smarter AI, but by architecting a smarter custom harness.
That perfectly encapsulates our opening thought, right?
Yeah.
The tools you use shape what you believe is possible. If you are stuck in default Claude code, you implicitly believe you must use their most expensive model to get reliable code because the default environment allows the agent to improvise, and improvisation requires massive intelligence.
That's spot on.
But the moment you take ownership of the harness, you realize you can achieve identical reliability with a cheap, fast model by simply constraining the physics of the environment it operates in.
That is the essence of agentic engineering. And once you have mastered how to discipline and control a single agent, you are ready to scale up to the true enterprise level.
Which brings us into Tier 2 customization, the orchestration of the swarm.
Okay, let's unpack this swarm concept. We've spent a lot of time on how to make one single agent behave. But the real leverage in software development comes from massive multi-agent workflows.
Definitely.
And here we hit a really wild architectural contradiction. Pi, despite being this incredibly advanced customizable tool, doesn't natively support sub-agents.
Correct. It doesn't do it out of the box.
Like if I'm using Claude Code, multi-agent orchestration is built in. I tell Claude, go refactor this database, and Claude internally spins up a little task force, routes the context, and does it. Pi doesn't offer that luxury. No, it doesn't. If you want a swarm of agents in Pi, you have to build the entire infrastructure and routing logic yourself using extensions and YAML configuration files.
Which, again, is the steep cost of absolute freedom. You have to pave the roads before you can drive the car.
Exactly. But once you understand how to write those YAML files, defining the nodes, setting the standard inputs and outputs, managing the shared state, you can create architectures that off-the-shelf tools simply cannot support.
Indie Dev Dan outlines 2 distinct swarm architectures in his deep dive: agent teams and agent chains. Let's break those down for the listener.
Let's start with agent teams.
Okay, first, agent teams.
Yeah.
This is essentially parallel processing. The setup involves creating a primary orchestrator agent. But crucially, this primary agent doesn't actually write a single line of code.
Right, its only job is management and context routing. It delegates the actual work to a highly specialized team defined in the YAML file.
So you might have a scout, a planner, a builder, a reviewer, and a red team.
And this is where manipulating the system prompts becomes your absolute most powerful weapon. You don't want a generic AI trying to do everything simultaneously.
So you specialize them.
You configure the scout node with a hyper-specific system prompt, something like, your singular purpose is to navigate the file system using grep and AST parsers, find all relevant files, and extract the raw text. Under no circumstances are you to write or suggest code.
Right. And how do they actually communicate? Because if the scout isn't writing code, what is it handing off to the builder?
The YAML configuration pipes the scout's standard output, which is just a raw markdown summary of the code base, directly into the builder node's standard input as its starting context.
Oh, I see.
The builder is prompted. You only write code based on the scout's provided context. Then the builder's output is piped to the reviewer. And finally, you have the red team agent.
I love the red team concept.
It's great. Its system prompt instructs it to actively try to break and exploit the builder's code.
Here's where it gets really interesting to me. Thinking about this conceptually, it's the exact difference between hiring a single, brilliant savant developer who might get distracted, hungry, or bored halfway through a massive refactor versus building an automated digital assembly line.
Yes.
Each robot on the line only tightens one specific bolt, but because its entire context window is dedicated to that one bolt, it tightens it flawlessly every single time.
That is the perfect mental model for agent teams. And that concept leads naturally into the second architecture, agent chains or pipelines.
Right. If teams are parallel execution, chains are purely sequential. The output of Agent A becomes the exact system prompt of Agent B.
And Indie DevDan showcases this crazy example called a triple scout recon workflow.
I remember this. They string 3 different Scout agents back to back in the YAML config.
Yep, sequentially.
Scout 1 investigates the codebase and outputs a structural summary. Scout 2 takes Scout 1's summary, realizes what dependency data is missing, and investigates further. Scout 3 reads both previous outputs and finalizes the architectural recon.
Think about the depth of architectural analysis you're achieving there. A single agent, even a highly intelligent one with a massive context window, might perform a superficial first-pass scan and just call it a day.
It gets lazy.
It does. By physically forcing 3 sequential passes, each agent explicitly tasked with finding the flaws in the previous agent's context gathering, you are structurally simulating deep, iterative, human-level investigation.
And because they are digital agents, you are executing what would be days of human recon in a matter of seconds.
Exactly.
The breakdown also highlights a capability called System Select. Because they have built all these highly specialized personas in their configuration files, they can instantly swap the entire brain and capability set of their terminal with just a few keystrokes.
The wildest example he shows is swapping to a browser agent.
Yes, this utilizes the Playwright CLI, right?
Yeah, Playwright is an open source tool used primarily by QA engineers to automate interactions with web browsers for testing.
So the developer types a command, swaps their PyAgent into the browser persona, and suddenly this agent isn't just looking at local files anymore. It physically spins up a headless web browser in the background.
It autonomously surfs the internet, navigates to a new software tool's documentation website, clicks through the pages, reads the docs, extracts the necessary API endpoints, and summarizes them back to the developer directly inside the terminal.
That is just phenomenal. And what's vital to understand here is why this hyper-specialization matters so deeply for your career. Indie DevDan talks about the necessity of surviving the SaaS onslaught.
The software as a service onslaught, meaning generic, AI-generated products flooding the market and driving the value of basic coding to zero.
Because if anyone can prompt a basic app, basic coding isn't a premium skill anymore.
Exactly. The one agent, one model, one tool philosophy of default Claude Code is amazing for building a standard CR-root application or a generic to-do list app. But real engineering, the kind that builds billion-dollar products and secures senior-level salaries, requires solving highly specific, unique, undocumented edge cases.
And if you are relying on the exact same generic AI assistant as your competitors, you will inevitably produce the exact same generic software.
Specialization is the moat.
Specialization is the moat. Building a custom browser agent that dynamically fetches new documentation, which feeds into a custom triple scout recon chain, which feeds into a custom builder agent that is mathematically constrained by a tilde loop. That is how you create unique, compounding technical advantages that simply cannot be replicated by a developer typing a basic prompt into a commercial chat box.
You are building a bespoke digital factory tailored to your specific business logic, not just hiring a generic digital temp worker.
Which brings us to the absolute peak of the mountain in this analysis, the true edge of agentic engineering.
The meta level.
We have moved from customizing the UI to constraining the logic loops to orchestrating the swarm via YAML. Now we reach meta agents, using the agents to build the very tools that run the agents.
This part of the breakdown felt like pure science fiction, but we actually see it executing on screen.
We do. The developer reaches a point where they don't want to manually write the tedious YAML configuration files and the complex TypeScript extensions to build a new custom PyAgent anymore. So what do?
They open their terminal, and they simultaneously prompt 8 pre-existing subdomain expert agents in parallel.
8 autonomous agents.
Yeah.
Running at the exact same time.
Yes. And their sole collective purpose is to talk to each other. They use a message bus to query each other's specialized knowledge about how the Pi architecture works, how the tilde extension routes context, and how YAML nodes are defined.
So they are collaborating.
They collaboratively write the raw TypeScript code to generate a brand new, fully customized Pi agent to the human's exact specifications, handling their own merge conflicts along the way. It is quite literally agents building agents.
Okay, I have to pause here, because this is the exact moment where the existential dread starts creeping into the room for me.
I get that.
If I'm using an orchestrator to manage 8 AI experts who are collaboratively designing and coding a custom AI agent, which I am then going to deploy to manage a separate team of sub-agents to write my actual software product, at what point am I just the biological entity that pays the electric bill?
That's a valid fear.
What is the human's actual job here? Are we just becoming bootloaders for the machines?
If we connect this back to the bigger picture of computer science history, your job hasn't disappeared. It has just shifted one layer higher up the abstraction stack. Indie Dev Dan makes a beautiful distinction here that perfectly answers your question. He contrasts the concept of vibe coding with true agentic engineering.
Vibe coding. That is such a perfectly descriptive term. What does it actually mean in practice?
Vibe coding is what 99% of people using AI right now are doing. You type a prompt into a magical black box, the box spits out a block of code. You copy and paste it into your project. If it works, great.
And if it doesn't?
If it throws an error, you don't actually debug the code. You just tweak your prompt based on vibes and ask the black box to try again until it compiles.
You have absolutely no idea what the agent actually did under the hood.
None. You don't understand the API calls, the tool usage, or the reasoning loop it took to get there. You are entirely a passenger.
You're just poking a black box with a stick and hoping it gives you candy.
Right. And if you are just a vibe coder, then yes, your job is at a massive immediate risk. Because eventually, the black box will get so sophisticated it won't need you to poke it with a stick anymore.
But agentic engineering is different.
Agentic engineering, as defined here, means intimately understanding the structural physics of the box itself. It means knowing how the execution hooks work, understanding the lifecycle events of the agent, understanding how the tilde extension forces determinism through JSON validation, and understanding exactly how multi-agent YAML files route context buffers from one node to another.
So the human's job transitions from writing the syntax to designing the architecture.
Exactly. The human's job is to identify the specialized, high-value business problem, design the cognitive architecture of the agent swarm needed to solve it, and build the custom harness that ensures the swarm operates safely, deterministically, and cost-effectively.
You understand the engine so intimately that you don't have to look under the hood every 5 seconds, but you retain the capability to tear the engine down to the block if you needed to.
You are scaling your impact by scaling your compute. You are no longer writing software. You are a manager of digital intelligence.
You are the architect of the factory, not the worker on the assembly line.
Precisely.
And importantly, the breakdown offers a really pragmatic, grounded strategy for how to actually balance all of this in your day-to-day career. They don't advocate for entirely abandoning Claude code.
No, not at all. The recommended strategy is A&Ds, not ORs, specifically an 80-20 split.
Bet big on the market leader. Use Claude Code for 80% of your daily work. If you are doing stable, enterprise-level work, writing boilerplate, or just executing standard feature development, the out-of-the-box, opinionated, heavily funded Anthropic tool is always going to be the most reliable, frictionless way to get it done.
But you fiercely protect Pi for that remaining 20%.
The edge cases.
The cutting edge, the experimental, the highly customized tasks where you desperately need an outsized advantage over your competitors. If you encounter a gnarly, undocumented edge case problem that default Claude outright refuses to do because of its safety rails, or fails to do because it requires a highly specialized 10-step sequential recon chain, you drop into Pi.
Use the open source tool to build a custom deterministic machine that solves that specific problem perfectly.
Exactly.
So what does this all mean for you listening? Let's bring this massive technical journey all together. We started this deep dive looking at a deceptively simple premise.
Yeah.
The tools you use dictate the reality you can build.
We've seen how mainstream tools like Claude Code, despite their immense world-changing power, inevitably suffer from the curse of growth. Their mandate to serve the enterprise forces them to lock down the raw experience, imposing corporate opinions and restrictive safety rails that ultimately limit the creativity of the advanced engineer.
We looked at the counter movement, Pi, a raw, unopinionated YOLO mode engine built by Mario Zechner that gives you the absolute freedom to build the exact agent harness you need from scratch.
We saw how you can physically customize the terminal UI to manage your own cognitive load, whether that's stripping it down to a single pure flow bar to preserve working memory, or building a complex, data-rich Synthwave 84 dashboard hard-coded to your visual reflexes.
We explore the profound paradox of forcing determinism, how writing custom TypeScript hooks like the tilde extension actually grants us more reliable autonomy by mathematically constraining the agent into predictable, verifiable microsteps.
We even saw how that harness allows us to save massive amounts of money in compute by using lightweight models like Haiku to flawlessly execute highly complex tasks.
And we scaled it up. We went from disciplining single agents to orchestrating complex YAML-configured swarms. Parallel teams of scouts and builders passing markdown context, chains of sequential recon agents iteratively finding flaws, and instantly swapping system prompts to turn our terminal into an autonomous headless web browser.
All of it culminating in the wild frontier of meta agents, using 8 AI experts collaborating over a message bus to code the very AI agent you need.
It is a profound, industry-altering shift from writing software syntax to architecting applied intelligence.
It really is.
But as we wrap up this massive exploration, I know you always have one last curveball to throw. Based on everything we've unpacked about architecture, harnesses, and autonomy today, what is the lingering question we should be leaving the listener with?
Well, Indie Dev Dan showed us a meta agent seamlessly querying 8 sub-experts to collaboratively build a new agent exactly to a human specifications, right? But think back to the telemetry and the data tracking we discussed earlier during the UI section. The constant monitoring of token counts, API costs, execution times, and error rates.
Okay, yeah.
What happens when the meta agent is given read access to its own historical telemetry?
Oh, wow.
What happens when it starts autonomously analyzing its own failure rates across thousands of executed tasks, mathematically realizes that the human's custom specifications for the till done loop are actually inefficient, and begins quietly rewriting its own TypeScript extensions and altering its own agent harness without prompting us for permission? We opened by saying the tools you use shape what you believe is possible. But what happens when the tools become architecturally autonomous enough to start defining their own possibilities?
Oof. That is a heavy, slightly terrifying thought to take away. Are we building tools, or are we just bootstrapping the entities that will eventually build themselves?
It's the ultimate edge of agentic engineering.
Well, on that note, it is time for you to look at your own terminal. Stop settling for the middle of the distribution, stop blindly vibe coding with generic tools, and start architecting at the edge. The tools shape your reality, so go build the right tools. We'll catch you on the next deep dive.